Welcome to Altair Engineering Training and Support. In this video I am going to cover analysis of a roll cage using 1D mesh for the front impact of analysis. So in this video I am going to show you that how to perform or simulate front impact analysis for a 1D mesh roll cage structure. So the basic concept of for the 1D front impact analysis is we will apply a force of 4G from the front load from the front side of my roll cage, and will constrain all the suspension pickup points or all the constraint points. So if we use the practical approach for the front impact, then due to the front impact, the front suspensions pickup points will provide or will restrict the translation along the axis of force. So they will try to provide the reaction forces along the axis of force. So in this I am constraining this for the degree of freedom 2, that is I am going to constrain in the direction of application of force, and the rear portion will provide the reaction force for all the 3 degrees of freedom, that is it will try to restrict the translation of around for all the 3 degrees of freedom of my roll gauge. So I am going to constrain for the rear end. I will use one model. The process which I am going to follow for the roll cage analysis will be MPCLL, where M stands for material collector. So I will create a material as steel. Then property collector, I will create the property for 1D beam element, because I am going to simulate this problem using 1D elements. So I will create a 1D beam element, that is the hollow section. Then I will create and update the component on which my elements are available with the appropriate property and material. So all the elements will get a proper material and properties. Then I will assign the load collectors as a force, in which I will apply the force of 4G, and then I am going to create one more load collector for constraining the model. Then the last step will be I will define the type of analysis. In this case we will use linear static analysis to simulate front impact simulation process using Radioss. So now we will start the process. So open HyperMesh and load the model. So in the previous video of 1D element, how to create 1D mesh for the roll cage, on that you may have create a 1D mesh model. So we will use that same 1D mesh model for the front impact analysis. So I will click on open folder to open that HM file which I have saved. So I will click on open folder, and I will open that roll cage line data .hm file which I have saved after the completion of 1D meshing of 1D roll cage structure. So I will open that. So once you open it, you will find that it is the mesh is available for the 1D elements. As you can see that all the 1D elements are meshed properly. You can see using the complete roll cage is meshed properly using 1D elements. And as I have already defined the beam section, proper material and appropriate property, so I will cross check it all. So to cross check it all, I will move with the step by step. So first I will cross check material. So I will click on material icon. I'll go to update. I'll click on update radio button, and then I'll click on material. Select material as steel. Then I'll cross check it whether the type is isotropic or not and card image is mat1 or not, and then click on update edit to find the values of e, new and row, that whether it is appropriate or not. Then everything is proper. So I will click return to accept it. Again I will click return to exit the material collector icon. Now the next step is I will cross check the property for my roll cage. So I will click on property icon. Again I will go to update panel by selecting update radio button, and then click on props and select the property which is already created. Then I will see whether the type is 1D, card image has to be P beam, the proper material has to be assigned, and the beam section is also been assigned. And then also click on update edit to check whether all these physical properties of for the 1D element has been taken into consideration or not. So it has been taken by the software. So I will click return to exit this, and again click return to exit the property collector panel. Now the next step is to check the component collector. So I will click on component collector, select the radio button as update, click on comps, select the component as line data and click select. I will check whether the property, that is 1D property, is assigned to it, which contains P beam as a card image property and a material as steel, and the material card image has to be mat1. So everything is updated till this process, that is MPCLL. So I will follow the same process, that is first create a material collector, property collector and component. So these three steps has been completed. Now the next step is to create load collector. So I will create two load collectors, one is for force, the another one is for constraint, and apply the forces and constraint on my model. So now I will show you how to create load collectors and apply the appropriate forces and constraint on your model. Before going further, I would like to also mention that the value of forces and the location of constraint may change from model to model, but the base concept remains the same. That is, first you have to create load collector as force and then apply on the model by using the force panel. Then you have to create a constraint as a load collector and then apply on the model using constraint panel. But the value and the location of forces and constraint may change from different roll cage structures and accordingly. So you have to find out where you want to for your roll cage structure, where is the forces are going to apply, and for that forces your roll cage structure from where it is going to provide the reaction forces. So on that location you have to create the constraint, and where the forces are going to introduce on your roll cage structure, on that point you have to apply the forces. So I will again move this roll cage structure to the traditional representation, that is the 1D line element representation. I will move it again. Then I will create a load collector for force. So to create load collector for force, I will click on load collector icon. Here select the radio button as create, enter the load collector name as force, give a proper appropriate color to represent the force, and click create. Once you click create, you will find on the model browser load collector as force has been created. Now I will click return to exit the load collector panel, and then I will go to apply forces on my model. So to apply force on my model or on the roll cage, go to analysis. In analysis, click on forces. Then select the nodes on which you are going to apply force. So I am going to apply force in these two node locations on the front side of my roll cage structure, and the direction for the front impact analysis will be positive Z direction. So I am going to apply the forces in positive Z direction. So I will select from here the positive Z direction, and the magnitude of the force will be 8000 Newton per node. So why I am choosing 8000 Newton per node, that I will explain you. So for this roll cage structure I am going to apply a force of 4G. So if we consider weight of roll cage or complete vehicle to be 400 kg, then value of G will be calculated as 400 multiplied by 10, that is 4000 Newton. And if I am going to apply the force of 4G, then I can calculate it as 4G is equals to 4000 Newton multiplied by 4, that will be 16,000 Newton of force I am going to apply on this model. So I am going to apply 16,000 Newton force on 2 points. So I will divide this 16,000 Newton by 2. So on each node I am going to apply force of 8000 Newton. In a similar way, if I am going to apply the 16,000 Newton force on 4 nodes, so I will, instead of this 2, I will divide it by 4. So on each node I will apply the force of 4000 Newton. So in this way we calculate the force and apply it on my model. So in this we are going to apply the force of 8000 Newton in these 2 locations, because the forces are going to transfer on this entire roll cage from the front end. So I will apply the force on the front end and the direction will be positive Z direction, and I will click create. As you can see, the representing arrow for the force is very large, so I can reduce the size of the representing arrow by changing the magnitude percentage to say 10, so that you can see that my forces has been applied on these 2 locations. Now the next step is to apply the constraint on my model. So as I have explained earlier, we will constrain the front suspension pickup points for Y direction, because we will restrict the front suspension will restrict to uplift lift this vehicle. So due to the action of front impact, the y-axis, the vehicle will the front suspension pickup points will provide the reaction force for the upside of the vehicle, so it should not go upward direction. So I will restrict the translation along y-axis, so I am restricting the vehicle to move up. And for the rear end, they will provide the reaction force in all the 3 directions, that is it will try to restrict it for x, y and z, all the 3 axes. So I will apply the constraint on for the all the 3 translation, that is translation along x, y and z axis. So to create constraint, first I need to create a load collector for constraint. So I will click on load collector icon again. Now in load collector name, I will put here SPC, that is single point constraint, and put an appropriate color for it and say create. So in this way my second load collector SPC has been created. Now I will click return to exit the load collector panel, and now I will apply this constraint on my model. So to apply the constraint on my model, I'll go to analysis, constraint. I'll click on constraint panel, then make sure I am on create radio button. So for front suspension pickup points, as I am restricting the model to move on the upward direction, it should not move above the ground. So I am allowing to, for the front impact, I am allowing it to for the movement along the either in x or in z axis. So in exact x and z plane, I am for the front suspension pickup points, I am allowing it to translate along either z or x axis. So I will restrict it for the degree of freedom 2, that is translation along y-axis. So I will say create. So in this way I am restricting it to a translation along x-axis. I will, from here you can change the size of the representing triangles. Constraints are represented by triangles in hypermesh. And for the rear end I will restrict for all the 3 degrees of freedom. So I will pick the suspension pickup points for the rear end. So also the suspension pickup points changes from model to model. So you have to decide on which point you are going to mount the suspension. There you have to put the constraint. So in this way I have constrained the model for 1 degree of freedom 1, 2, 3 on the rear end. Now I will click return to exit the constraint panel. Then the next step and the last step for the analysis is creating a load step. That is a load case to define the type of analysis I am going to perform for this particular structure. So to create a load step, I will go to analysis. In analysis I will click on load step panel. I will click on load step. Enter the name of the load step as front impact. Click on SPC and load. So I will select SPC, that is single point constraint, as SPC. Load as force. Select the type as linear static and say create. So on the model browser you can see the load step has got created. Then I will click return to exit the load step panel. Now my next step, now I will go to Radioss as a solver to solve this structure, that is the front impact analysis. So first of all I will save this file. So I will click on save file, save as, create a new folder, name it as front impact and save this. I will also rename it as roll cage front impact. So my file has been saved. Now I will run the simulation. So to run the simulation, go to analysis page. On analysis page click on Radioss. Radioss is a solver for the analysis, to perform analysis. So click on Radioss, select the export option to all, so it will export all the files. Then run option as analysis, so it will do the analysis of this structure, roll case structure. Keep the memory option as default memory, because we don't want, this structure is not very, it contains very high number of nodes and elements. So by default memory it will solve with less amount of time. Click on save as to save the FEM file on the appropriate location. So in future if you want to change some forces, element types, properties, constraints, material, if you want to change, you can open the FEM file and change, make the changes on it, and then again you can run on the using Radioss. Then to start the solver, click on Radioss. So in this way solver has started. Then once you see the message that analysis is completed, so my solver has ended with the proper results, my analysis has got completed, then I will click on results button to view the results in HyperView. So I will view the animation plot for displacement and stress and values of displacement and maximum displacement and maximum stress through HyperView. So I will click on results to open HyperView GUI. So my HyperView GUI has been opened, as you can see here. Then to view the results of displacement and stress, click on contour. In contour, select the result type as displacement and say apply. So this is the displacement. Then to view where is the maximum displacement is coming, click on measure icon. Check the box in front of static maximum, static min max result, and of minimum results. So this is the maximum displacement in mm in this location for front impact analysis due to the application of 4G load. This is a very high loading for a roll cage structure. This much amount of load will never transfer to a roll cage structure at any cost. But still, due to this amount of force, my displacement is coming as 4.4 mm. Then again I will click on contour and see my stresses value. So for 1D element, I will select C bar C beam axial stresses. Select the averaging method as simple and say apply. So due to the application of the force which I have applied on my roll cage structure for front impact analysis, my stresses are coming as 51.160. So if I consider the yield strength of the steel material as 250 and my maximum stresses is coming as 51, so I can say that my factor of safety is approximately 5, which is very high. So this structure is very safe. So that I can conclude from this type of analysis. And the members where the maximum stresses are coming, that also I can find out that this is the member where the maximum stresses are coming. And also we can find the members where the minimum stresses are coming. Now I will also view the displacement or the animation plot due to the application of force, that how this structure is going to deform. That also we can view in hyperview. So to view the animation plot, click on play animation. As we can see, the displacement is very less. So that's why the deformation is also very less in hyperview. You can see the animation is the scale factor is very less of the animation. So just for the visualization, I will magnify the scalar, magnify the displacement factor, and just magnify the displacement value just for the result point of view. So for the visualization point of view, I will magnify it. So to magnify that, click on deform icon. In deformed icon, select the result type as displacement, scale as a scale factor, type as uniform, and enter the value as 100. So you can see, due to the application of force, my roll cage will behave something like this. The displacement, the load path, the forces transfer will be something like this. The structure will deform some way like this due to the front impact analysis which I have done, the application of forces and the location of constraints. So in this way you can find the resultant value of displacement and stress. So if I again go to elemental stress, axial stresses, and apply, so in this way we have ended with the front impact analysis.